This is Advanced Varnish Cache with Daniel Bartholomew, CTO and co-founder of Section.io. Today we'll be talking about how to control the hash and exactly what that means. And with that, I'll hand it off to Dan. Dan, go ahead.
Thanks, CJ, and thank you all for joining today. Today we're going to be is a continuation of some of the previous webinars where we've been introducing Varnish Cache, talking about some of the fundamentals of how Varnish Cache is configured. And today is an extension of that series where we're talking about how do we get Varnish Cache to cache in a more customized way. So today we're going to go through, firstly, a quick primer on Varnish again, and then we're going to speak about how does Varnish actually know what's in its cache, which is the first point there, Varnish hash basics. Then we're going to give some examples, some real-world examples of things our customers have used Varnish for, like caching the same URL, but getting a different experience for desktop and mobile. Then we'll also talk about how we can cache the same URL for people in different countries or different regions. And then we're going to conclude with a final example of how you can use Varnish to conduct some A/B testing without sacrificing any performance. A quick primer on our business, Section.io. We're an application edge platform that turns the old CDN industry into a true developer's tool. That means that instead of the CDN existing only in the cloud, Section.io brings a fully customizable and programmable application edge that's distributed around the world just like a CDN. Instead of the legacy CDN model of one size fits all, our system allows each website on our platform to choose what technologies should be running inside at the edge. And one of the most popular choices people make on our platform is to run Varnish Cache, and that's why we've been running this series. Our business is based in Boulder, Colorado, but you might tell from my accent that I'm not a Colorado native. Our business was actually started in Australia around 5 years ago. And just to quickly remind everybody where Varnish lives inside websites deployment, Varnish sits between your end users and your application code. And Varnish is deployed in a couple of different ways. Sometimes it's deployed at the origin, behind the load balancer, between the load balancer and the application, or Varnish can also be deployed on a distributed application edge as Section.io provides. But where we're operating today is where Varnish is sitting between your code and your users. So the title of this talk was Controlling the Hash. Now, what is the hash? And now we all know Varnish is a content accelerator that keeps copies of your content in memory or on disk inside a server. So Varnish is a cache that stores your content. But when a HTTP request comes into Varnish, Varnish needs to find that content. And the way that it does that is that it maintains an index that says, hey, the homepage HTML is in this part of memory, or the logo PNG file is in this part of memory. And that index maps the HTTP request that's coming in into a specific part of Varnish's memory so that Varnish can return the correct content. Now, the underlying mechanism for what Varnish uses for this is essentially a hash table that says if the URL for this request says it's the home page, then here is the address of the content that you need to send. So it's really important to understand here that when Varnish is looking up content, it's only able to use properties on the HTTP request to actually find that content. It's all about the requesting properties. So by default, Varnish does cache things, and it does cache based on the code that you can see on the screen here. The code that you're looking at here is the built-in VCL. And just to remember, VCL is the Varnish control language, which is how you actually program Varnish to do things. So if we dig into what's actually happening here, when Varnish is saving something into the cache, this function here, sub VCL hash, controls how what components of the request are used to actually index the content. Now we can see on the first line in this function, the first component is the request URL. So Varnish uses the URL of the request to make the cache. So for example, the URL might be simply / for your homepage, or /images/logo.gif. So when a request comes in for one of those things, Varnish looks at the request and says, hey, this is a request for the logo. Let's have a look in the index and see if I've got something that I can return. The other parts of code here actually let Varnish have different caches for different HTTP host headers. So if I'm running a couple of websites through the same Varnish instance, the homepage for one domain name will be in a different area of the cache to the homepage for a different domain name. And that is this line of code here, #_data rec HTTP host. In some cases, the host isn't actually available, and Varnish by default will fall back to the server IP. Now, this default configuration has some implications. So what does this mean? Varnish treats URLs in a case-sensitive fashion. So if you look at this first bullet point here, we've got two URLs that look like the same thing. However, because of the capital A on the second URL, Varnish is actually going to maintain two copies of this content, one for the lowercase version and one for the uppercase version. So when you're trying to maximize your cache hit rate in Varnish, it's often worthwhile to change the way that Varnish is hashing the content when it puts it into the index, so that everything lands on one URL that you choose. So in this example, you might choose to lowercase everything so that you only have one copy of /about in your index, and it doesn't matter how the browser makes a request. Both lowercase and uppercase are going to actually get cache hits. So this means that you're going to have better user experience, and also the server is going to have more memory available to it because it doesn't need to have duplicates inside the cache. Another really interesting thing to think about inside the way that Varnish actually manages the hash by default is that when we talk about the URL from that previous slide, rec.url, the query string is actually included in there. So in this example here, /about ABC = 1, 2, 3 will actually be a different object in the cache to the /about that we cached in the example above. So another thing you want to consider when you're trying to maximize your cache hit rate is how should Varnish handle those query strings? And there are some really well-defined patterns that you can use to actually clear up the query strings, because often query strings don't affect the way that the content is generated. They actually affect client-side libraries. And a really good example of that is when you're using something like Google AdWords to send traffic to your website, the URLs get query strings appended about all of the campaign monitoring. For example, the GTM source and GTM medium query strings get appended on to the URL, but they are not interesting to the server. The server responds with the same content either way. The reason that those query strings are there is so that the Google Analytics JavaScript library can pick them up and actually send them back to Google for tracking. So that's a quick roundup of how the default behavior of Varnish works, and some things that you might want to be interested in to optimize what Varnish is doing for your website. Now, the thrust of this talk is how do we customize the hash? And what we want to do is extend the way that Varnish is indexing the content so that we can have a more efficient index and still give users a really good experience. Now, in your own custom VCL file, you can write additional code. As you can see on the bottom of this slide here, you can write your own VCL hash subroutine and include additional properties into the hash. So we've written a kind of pseudo code example here where we're including some arbitrary HTTP header. Now, oftentimes, a web application will respond differently depending on if it is a mobile client or a desktop client. So let's consider the situation where somebody visits your homepage, and based on the user agent that's incoming, you're going to deliver different HTML depending on if it's a mobile user agent or a desktop user agent. Now, in this example here, what we've configured Varnish to do is, as soon as Varnish sees the request, this VCL receive function is called. And what we say is, if the request's user agent contains the phrase iPhone, then let's add an additional HTTP request header called device, and let's call it mobile. Otherwise, we're going to set the device to desktop. Now, what's going to happen here is Varnish is going to make a request back to your origin, and your origin is going to see this new HTTP request header called device. And your code at your origin can respond differently if it sees mobile or desktop. Now, after your origin generates that different content, it's going to return it back to Varnish, and Varnish is going to save it in its cache. But what we need to do is we need to tell Varnish this is the mobile version or this is the desktop version. So we customize the VCL hash function, and so to tell it to include in the hash data the rec HTTP device header that we set on VCL receive. So after that first request from an iPhone, the origin generates a mobile page and sends it back to Varnish and says, we have saved in our cache a version for mobile. When the next user browses the website from an iPhone, the VCL receive function will set the device the device header to mobile again. And then when Varnish goes to look up in its cache, instead of just looking at the URL, it's also going to include this, this header, so that instead of picking up the desktop version, it's going to pick up the mobile version and deliver it immediately to the user. So this way, we've got two versions of the same URL cached in the system. Now, one thing to think about here is that, yes, we've just given a fairly trivial example for mapping iPhones, but you can obviously broaden this out for many different device types and tablets and other form factors. So let's think about what's happening here again. The browser makes a request to Varnish. We look at the user agent header that the browser sends to us, and we kind of normalize that into one consistent header that says mobile or desktop. We could have included the user agent in the hash instead of this custom device header that we've set. But the challenge with with including the user agent in the hash is that there are so many different browsers and so many different ways that user agent strings appear over HTTP that would result in a highly fragmented cache and a poor cache performance, and also consume unnecessary memory that could be freed up for other objects inside Varnish. So we normalize that user agent header and set a new request header. And then we send it to the origin, and the origin needs to look at this new header and say, hey, Varnish is requesting on behalf of a mobile user, so let me respond with mobile content. Or Varnish is responding for some other device, let me give the default treatment, which is generally a desktop view. So the origin responds with different content based on that request header. And then we tell Varnish to include that in the hash table that manages the index of where inside Varnish's memory is the mobile version, where is the desktop version, so that when the next user comes along, it's able to look it up really quickly. Let's move on to another example here. And this example is using some Varnish extensions. And Varnish has an extension model called VMods, Varnish modifications. In this example here, there is a GUIP module. So what we're doing is exactly the same as what we did in our mobile versus desktop version. In the VCL receive function, as soon as the browser makes a request to us, we're actually adding a new request header called X country code. And what we're putting in there is the result of a GUIP lookup. So I'm sitting in the US right now. What we're going to be doing here is when I make a request to Varnish, Varnish is going to add in a new HTTP request header, which says X country code equals US. And that's going to get sent back to the origin. And then the origin might do something like show me US dollar pricing. Whereas if I was in Australia, the origin might send back to me Australian dollar pricing. And then again, same example, same code as before. In the VCL hash function, we include this request header in the hash data, so that when CJ comes to this website, he's coming from the US. Varnish says, hey, I've got a request for the homepage URL, and it's a request from the US. Do I have a US version of the homepage in my cache? Yes, I do. Let me immediately return for a really good user experience. Now, we can layer in more and more complexity here. One of our customers actually started to work on a new website design. They were originally a desktop-only website, and they wanted to move to a responsive design, but this e-commerce business was really wary about what impact would this change from the old design to the new design have. Because the old design had been really heavily optimized, it used to respond really quickly. And the new responsive design that they were trying to launch hadn't reached that level of maturity where it had been really heavily optimized. So what this customer wanted to do was to make sure that when they were running their A/B test, performance of the old design and the new design wasn't a consideration. They wanted to make sure that the results that they were getting when they were tracking how did this design change affect conversion, they wanted to make sure that both of the systems had equivalent performance so that nobody would say the new design isn't working and the underlying cause be that design was slower. So in this example here, we're following the same pattern as before, where in VCL receive, we enrich the HTTP request with some additional request headers, and then include this in the hash data. So you can see here, inside the VCL receive statement, we've got an if statement that says, if given a random number between 1 and 100, it's greater than 50, show them the old design. Otherwise, show them the new design. So this way, we get basically 50-50, a 50-50 split for each customer, some 50% going to the old design, 50% going to the new design. Now, if you wanted to run an A/B test with a smaller number of users, perhaps you just wanted to roll out your design changes to 5% of users, then you would tweak the way that this random allocation is working. So this pattern is exactly the same as before. Now, this pattern has a small challenge to it at the moment, and that's the reason this slide is titled Part 1. If we just went live with this and I sat there refreshing the homepage in my browser, I'm going to flip between the old design and the new design, because there's no logic in here which says, if I've been shown the new design, keep me on the new design. So if I sat here and refreshed, I get old, new in a fairly random looking manner. We can improve that situation by using Varnish to actually set a cookie based on the decision that's made here. Now this is layering in a little more code on the previous slide here. And what we're saying here is when I go to the website, if I've got a cookie that says what design mode I'm in, then let's set that HTTP request header to keep me on that design. And then when Varnish looks up in the cache, it will always show me the old design over and over and over and over again. But if I don't have this A/B test name cookie, then let's just follow the same logic as before, where 1 in 100, if, sorry guys, my Zoom has just popped up as, sorry guys, had a small hiccup here. So if the browser doesn't have this cookie set, then let's randomly allocate them into the old and new design. We don't need to change anything about the way the hash is working, but what we do need to do is when we actually send the response, we need to set an additional set cookie header so that my browser actually gets a cookie. And what we do is we set a cookie in the browser saying A/B test name equals old design or new design. And that means when I come back to the home page or whatever page it is, I now have the cookie, which means that I can stay in the correctly allocated bucket for this A/B test. So that's how our customers are using Varnish to actually get better caching outcomes for their website and do more advanced things. A lot of these techniques can be further expanded. For example, in that A/B testing scenario, you could actually use some input from your database to say which people are allocated to the new design. You might say, I only want to show the new design to people inside the office. And so you can actually go through and in your user database say, everybody who's got our corporate email address should end up with the new design. However, we're not really ready to show that to the public yet. And then we can do phased rollouts. But as we roll features out, we don't need to skip caching, which will penalize the performance of the new work that we're trying to release. So I'm going to open up for questions now. Here's some references that you can go to on our website. Our documentation has quite a lot of VCL examples. Our platform, unlike traditional CDN, actually gives you a development environment on your local computer where you can actually spin up Varnish and run these examples on your local PC without having to think about how do I set up Linux, how do I install Varnish. It takes away a whole bunch of those hassles. Section.io also open sources a tool called vclfiddle.net, kind of like JS Fiddle, if you're familiar with that, where you can actually just go straight to the website, type in some Varnish, and hit run and see what the behavior of it is, which is a pretty cool little prototyping tool if you want to run something really experimental before you want to take that out into your own Varnish installation or a distributed Varnish system like Section.io. And of course, you can email us, and we're going to be running some more webinars like this that kind of go deeper and deeper and deeper into Varnish.
Thanks, Dan. I've got quite a few questions here. I'll start at the top. So this person is asking, is the caching only working for static websites? And how about dynamic content or RESTful services?
Sure. So the easiest use case for caching and really where legacy CDN has lived is static files. And Varnish does a very good job of caching static files. But what most legacy CDNs are missing is this really deep control of how the content is indexed. So when most of our customers use Varnish for caching dynamic content, and there's a couple of strategies that our customers follow for dynamic content. And the two primary ways of doing that are via hole punching, and there's two strategies for hole punching. You can make what seems to be dynamic content fairly static by layering in all of the dynamic content via AJAX calls. So essentially, in that scenario, you for your homepage, you take out all of the personalized pieces out of the main HTML, so that you have one HTML regardless of who the user is, and then send that down to the browser from Varnish's cache, and then the browser will then make AJAX calls that can go to your origin and load in things like welcome Daniel, and you have 2 items in your cart, for example. The other strategy to do hole punching is that Varnish has a technology inside it called edge site includes, which is very, very similar to the AJAX method, but instead of the browser making those HTTP requests, Varnish will actually make those AJAX style calls on your from the server, and then and then send the content directly from Varnish, so that the browser doesn't have to make those AJAX requests.
Thanks, Dan.
Sorry, I think there was a second part to that question about
the RESTful services. RESTful
services. So RESTful services have got some really good caching opportunities. When we look at cacheable content, it generally falls into a few categories. There's content that's cacheable for everybody. For example, if your RESTful service had a method that said, give me all of the countries that I can ship to, that method is, API call is going to give the same results for anybody who comes along. And then there's another category which is personalized. So it might say, Daniel, what is your account balance? And these things are generally fairly uncacheable. Sometimes though, those things that you think are uncacheable are often worthwhile caching for a really short lifespan, because if you get a flood of HTTP requests, it's often best to simply return the same response. For example, if I made 100 requests to get my account balance within 1 second, then it would be worthwhile protecting the system so that the back end wasn't getting smashed by that wave of unusual traffic.
Awesome, thank you. Here's another good one. I have a hard time understanding how I load Varnish with info about which design is the new and which is the old one. Probably referring to the A/B testing.
Sure. So let's just go back to some of these examples. Sorry guys, I've pushed the wrong button again. Let's start that. So let's bring up that code again. Just getting there. Okay, so this was the A/B test code. Now, see the third line. What we're doing is we're adding an HTTP request header. So when Varnish makes a request to your backend will get all of the normal HTTP request properties, like what is the user agent, what is the HTTP host, what are the cookies that are being set on this HTTP request. What Varnish is doing here is adding in a new HTTP request header, so that when your application receives this request, you can write logic in the application to say, if the A/B test name request header is present and it says old design, then give me the old design HTML. So these HTTP request headers that Varnish is setting here get appended to the HTTP request that Varnish is making to your origin. and then your origin can see these new HTTP request headers and react accordingly.
Awesome, thank you. Here's another one that kind of expands on top of that. Can Varnish fetch content from different servers and use the same concept as the A/B testing example?
Definitely it can. In Varnish, you can specify multiple backends, and I don't have a code example here, but based on request properties, you can write a line of VCL to say, hey, go to server, go to cluster 1 or cluster 2, depending on if it's the old design or the new design. And that is a really good strategy for launching your new system, where you can have two completely clean code bases, one running the old system and one running the new look and feel. And that means inside your code base at the origin, you don't need to have a whole bunch of if old design do this, else do this. You can just have two really nice clean code bases. Section.io extends on the way that Varnish does that. There are some strategies that Section.io layers on top of default Varnish, which is what we're covering today, just default Varnish, that can help you improve that situation.
Awesome, thank you. Here's another good one. How to deploy the Varnish cache, which part of the network does it sit, and is it persistent?
Sure, so there are some ways to deploy Varnish's cache so that it's persistent, but that is not generally how Varnish's caching is run. So there's a couple of models for how you deploy Varnish. The older model for Varnish, and where it really got its first success, would be to deploy Varnish at your origin behind your load balancer. So let's consider if you were running Amazon, running a website in Amazon, you would configure your DNS to send all of the traffic to an elastic load balancer, and then the elastic load balancer would generally send traffic to EC2 instances that are running your application. When you bring Varnish into that system, you would put Varnish between the load balancer and your EC2 instances. So you'd essentially fire up a new layer of EC2 instances to run Varnish. So then the traffic would go to the load balancer, then to Varnish, and then to your application. And if Varnish was restarted or the server crashed, typically that would mean that the cache inside Varnish was empty and would need to be filled up again. And because Varnish's cache model is completely on a pull-based model, the Varnish cache would fill up again as users were browsing the site or as HTTP traffic was coming into the system. The Section.io model changes that a little bit. Section.io can be deployed at the origin, just like if you were installing Varnish yourself. And it would bring a whole bunch of advantages, like giving you a developer lifecycle and effective monitoring and metrics. But most of our customers choose to run Varnish at the edge, which means inside the servers that Section.io runs around the world. So when a customer comes onto Section.io, we launch Varnish here throughout a whole bunch of data centers, and then as people, and then you point your DNS at our system, and then just like a traditional CDN routing, customers from East Coast US would go to East Coast data centers where Varnish is running, West Coast to West Coast, Australia to Australia, for example. And that means that you get all the benefits of running Varnish without having to have additional servers running inside your origin infrastructure, and you get to avoid all of the tuning and high availability and security that a business like Section.io brings when we manage that for you.
Awesome. Thanks, Dan. That was the last question we had today. Thank you everyone for joining, and we'll be having some other webinars on Varnish material and kind of how Section.io is making your life easier in that realm. So everyone have a great rest of your afternoon, and if you have any questions, you can reach out to us at info@section.io, and we're more than happy to talk about your architecture or getting set up with something on Section.io. Thanks, everyone.
Thank you.